All right, my beauties, our last set of notes for today, we are looking at our third transformation, which is a rotation. Rotations are also rigid transformations, meaning the shapes are the same size and shape. They're congruent to each other. So a rotation takes a shape and turns it to a new position. The original shape is still called the preimage, and the new shape is still called the image. We have three basic rules. Normally you've seen this before in junior high, and most teachers teach you with patty paper. Since we're online and I really can't give you patty paper, and because you've already seen patty paper, I am going to show you how to do this with these basic rules. If you are turning a shape 90 degrees clockwise or 270 degrees counterclockwise, what happens is the X and Y flip-flop and the X changes signs. So the Y moves to the front, the X changes signs and moves to the back. If you want to rotate 180 degrees, a half circle, you do a 180. Both of these just change signs. Opposite X, opposite Y. If we want to do 270 degrees clockwise or 90 degrees counterclockwise, the X and Y again are going to flip-flop, but notice this time it's only the Y that changes signs. The X does not. So the X just moves to the back, the Y moves to the front and changes signs. Alright, so here's our example. Here's our original triangle with our original three vertices. And this says to rotate 90 degrees counterclockwise, and I'm realizing I did clockwise. Lovely. Okay, we're just going to say change this to clockwise just because I already did the notes. So cross off counter and just change that to clockwise. So this is clockwise. I can read carefully, yes. So here's our original triangle with the three vertices. And clockwise would be Y opposite X. So the -3 becomes +3, and the -4 stays -4, but they flip-flopped. So the opposite of 0 is still 0, and the -1 moves up front. The opposite of 0 is still 0, and the -3 moves up front. So those are our three new points. And again, this is a clockwise, so cross off the word counter. This is a clockwise rotation. And all of these we're turning around the origin. So the origin is our center of rotation. Okay. All right, and how you can tell is if you look at the same letter, if you connect to the origin and make an angle between the I and the I prime, or the J and the J prime, or the K and the K prime, you get a right angle. So if I connect this to here, I get a right angle. If I connect to here, I get a right angle. Even here, if I connect to the origin and then connect, I get a right angle. All right, so this example, here's our original shape. This time it says to rotate 180 degrees. Notice it doesn't say clockwise or counterclockwise because it doesn't matter. It's half a circle. Whether we go clockwise or counterclockwise, you end up in the same place. And I like this one. This is the easy one. All you do is change the signs. So 0, 1 becomes 0, -1. 0, 2 becomes 0, -2. 2, 3 becomes -2, -3. 4, 0 becomes -4, 0. So we plot those points, and there's our image. And again, notice it's rigid. The pre-image is congruent to the image. All right, so example 2, what I do is I connect, example 2, we are given the rotation, and we have to figure out the rule. How far did it rotate? Did it rotate clockwise, counterclockwise? So what I do is I go to the origin, and I connect to a letter and to its prime. So in this case, when I connect to G and G prime, I get a straight line. A straight line is 180 degrees. So this is a rotation of 180 degrees. And it works with all of them. If I connected the origin to H and the origin to H prime, I would get a straight line. All right, so this one, I take this point and connect it to the origin, and I take this point and connect it to the origin. And look at, there's our right angle. So we have to look at the primes. And I'm going from here to here. So we rotated from here to here. So this actually has two choices. I said that would be 90 degrees counterclockwise, or you can shorten it to CCW for counterclockwise. So if I went from here to here, if you wanted to go around the long way, that's fine. That would be 270 degrees clockwise. So remember, this is clockwise. This is counterclockwise. Okay, and I know that's getting harder and harder to learn because everybody has digital clocks now instead of the analog clocks. So don't know what we're going to call it in the future. So clockwise, counterclockwise. So from here to here, 90 degrees counterclockwise. And like reflection, rotation has symmetry that goes with it. It's called rotational symmetry. And this is when the shape turns at most 180 degrees and lands perfectly back on itself. Okay, so we have the center of rotation is just right in the middle of the shape. So I'm just going to take the square and turn it so that A would land right here, and then it would still look like the exact same square. Okay, and then if I turned the A and put it here, it would still look like the exact same square. And then if I turned the A and put it here, it would still look like the exact same square. And if I turned the A and put it back here, it would be back to its original starting space. So what happens is it took 4 of those little turns to get the A back to where it started. An entire circle measures 360 degrees. So 360 divided by 4 is 90 degrees. So to go from here to here would be a 90-degree rotation. If I turned it one more time to get it to here, well, 90 plus 90 would be a 180-degree rotation. And I stop. Notice I said at most 180. This is helpful if you were designing something on a computer and you can make it rotate, but why would we go over 180 when we could just go the other direction? I could go 90 degrees clockwise, I could go 90 degrees counterclockwise. So that's why we stop at 180. Because as soon as you go over 180, it would have been easier to go the other direction. All right, so here I have a 6-pointed star. So here's my letter A. If I turned and moved it so the A landed here, this star would look exactly the same. Then if I turned it again and put the A right here, the star would look exactly the same. I could turn it again and put it here. The star would look exactly the same. I could put the A right here. It would look exactly the same. I could put the A right here. It would look exactly the same. And then back to the original spot. So notice to get the A back to the original spot, it took 1, 2, 3, 4, 5, 6 of those little turns. And again, a whole circle is 360 degrees. So 360 divided by 6 is 60. But then if I added another 60, the A would land here. So 60 plus 60 is 120. Or if I added another 60, the A would land here. So 120 plus 60 is 180. And then I stop because after that it would have been quicker to go the other direction. So we stop at 180, and that finishes up today's notes.